wait for your introduction.
Okay, so let's do this thing very quickly. This is the last session and this, for this team. We're supposed to have one keynote speech and 4 speakers, followed by panelists, a moderator I should say, and a few panel members. So we'll see how it goes. I'm not sure who is here already, but you see a few of them here. My name is Joseph Bayena. I'm from McMaster University in Canada. So it's a pleasure for me to introduce our keynote speaker, Professor Tessema Guebre from the USA. Dr. Tessema is currently a program director at the US National Science Foundation. During his service of over 16 years at NSF, Dr. Tessema has managed several programs: the Condensed Matter Physics program, the Instrumentation for Materials Research program, the Mid-Scale Instrumentation program. He was program director for the synchrotron facility at Cornell University, the US National High Magnetic Field Laboratory, the Center for High Energy Neutron Scattering Facility, and distributed the National Nano Fabrication Coordinator Network. Prior to joining NSF, Dr. Tessema had 20 years of experience in academia at the University of Southern California, Memphis State University, and at Clemson University, where he rose to the rank of full professor. Dr. Tessema is involved in many NSF programs to broaden participation of the science and engineering workforce. He is a founding member of the Ethiopian Physics Society in North America. It's my pleasure again to welcome Professor Tessema.
Thank you very much. Okay, so I have a couple of disclaimers. One is that I work for the U.S. government. The National Science Foundation is what we call an independent agency of the U.S. government. And therefore, I'm limited in what I say, and whatever I say is only my opinion. It does not reflect the position of the government or the agency I work for. The disclaimer is very important. But I just quickly, the NSF is a funding agency, does not own a lab. But it's a major funding agency in the US for US universities, academia, for education and research. Its portfolio is to support big new ideas, to support the people. That means education and training of a globally competitive, diverse workforce, and to support the university community with the infrastructure, the research instrument, equipment, and computer infrastructure that is critical for the advancement of science. It's a science-driven organization. Its vision is to create and exploit new concepts of science and engineering to provide global leadership in research and education. That is sort of a brief introduction of NSF. I thought I would give you NSF by numbers, just to put in context of what we've been discussing today with the big picture. I should put my glasses even though I know the numbers. It supports 93% of the university research in the United States. Its budget is $8.1 billion. It's proposal driven. That means the university community generates ideas. We engage the university community and outside the university community to evaluate the ideas, and we recommend funding. And annually about 48,000 ideas, proposals come to NSF. 12,000 are generally funded, and so about 20% of success rate. So in terms of numbers, that's what it is. But here is the idea I want to share, that what is NSF's big vision for the future, like the next 10 years, right? Because we're here projecting the next 30 years. But the idea is that how different is it from what we're talking today? My own view is that the global challenges that have been discussed today, the challenges that have been discussed today, are mapped very well with the challenges that the developing world or the developed world in the United States faces. And so in the future, NSF has what it calls 10 big ideas. Of course, one is to understand the universe, so the origin of the universe. The other is understanding the rules of life, predicting plant phenotyping and stuff like that. The other, something that was discussed this morning, is the emergence of the quantum technology. As you know, that the world now is sort of understanding is that we are at the dawn of what's called the quantum revolution. The nano revolution has come to a certain level. In the future, the next 30 years, your devices would be quantum-based devices, quantum sensors, quantum cryptography, quantum information technology will be the target. So these are the big 10 ideas. Of course, the harnessing big data, the data revolution, was discussed this afternoon, and that's what also NSF is trying to promote. Navigating the Arctic is an important for NSF, but also the development of the future workforce. So to tackle the frontiers of technology, right? So and the idea is that how do you bring different disciplines together to address these big issues? But in doing all that, NSF also has issues of diversity. How do you bring the diverse community together to contribute to the advancement of science within the United States? As you know, the United States is a very highly diverse country and includes